Good, how are you?
Good. Did you have a nice spring break?
Yeah, did you have a
Oh
break?
yeah, I always enjoy it. Gives me a chance to play a
Good.
little golf early in the season. So
Oh, nice.
yeah. So it looks like we're solving triangles tonight.
Mm-hmm.
Okay. Using the law of sines and probably the law of cosines,
Yeah.
and having to deal with the ambiguous case of the law of sines probably also. Yes or no? Have you?
I don't think so. At least she hasn't said that.
Okay. Well, we'll find out whether any of these problems have the ambiguous case, and I'll show you along the way how to solve the ambiguous case of the law of sines. If you haven't had it, you will. So it won't hurt you to talk about it. Basically, where you can have the ambiguous case of the law of sines is this first question, 15. And the reason is that we have angle, side, side, or side, side, angle, which is different than side, angle, side, or angle, side, angle. This is a very unique situation where you have an angle, you have the adjacent side, and you have the opposite side. And furthermore, this angle that we know is less than 90 degrees.
Mm-hmm.
With those conditions, it's possible that we could have the ambiguous case of the law of sines. So let's solve it. So what am I going to do to solve that?
Um, let's see. Do you have to set up a ratio or a
Yeah,
proportion?
whenever you're solving a triangle, they're going to give you 3 of the 6 pieces of information. They gave us a side length, and an angle. So as long as we have the relationship between an angle and its opposite side, then we can always use the law of sines.
Mm-hmm.
So since we see that relationship, we have the sine of 34 degrees is to 30. That is a fixed relationship for this whole triangle. It's going to apply to
Mm-hmm.
angle A. It's also going to apply to angle C and side C. What's that going to be equal to? What's the first thing we can solve for?
Um, A or
Okay.
angle A.
Yeah. So what's this equal to?
So sine A over 33.
Right. So sine A equals, what is this number? Do you have your calculator handy?
Yeah, I do. Um, 1 second. So, um, I got a decimal. Oh, so is it, I think,
It better be a decimal, yeah. If it was a
yeah.
number greater than 1, then this is an impossible triangle. In other words, sines always have to be between -1 and +1. So what do you
Okay.
get for sine of A?
I got 0.6151.
Okay. Now solve for A. How do you solve for A? Angle A.
Um, oh, do you have
Take
to
the
subtract?
inverse. In other words,
Oh,
basically
right.
what I'm going to do is I'm going to take the inverse of both sides.
Okay.
And that'll leave A alone on the left.
Okay. So,
Make sure you're in.
37, or it's 37.96, so is it like 38?
And you're in degree mode?
Yeah.
Okay. Now, since we are in a situation that could be the ambiguous case of sines, there's actually two answers for angle A. The first quadrant and the second quadrant answer. What is the second quadrant answer? Whatever angle is supplemental to that.
So 180 minus 37.96. So it's 142.04.
Now, here's what we have to determine if that is a possible solution. Well, the only other angle we know is this 34-degree angle. So could A actually be 142.04? The answer is yes. So it can be either that or that. And so we actually have two triangles that fit this bill. There is the one that I drew, and then there's this one here. And in both cases, that angle is 34 degrees. This side is 33, and this side is 30. The difference is, in this triangle, angle A is, please, let me round off here, 38 degrees. And in this triangle, angle A is 142 degrees.
Right.
Now, the way I check to see if this is possible or not is if I add this to 34 degrees and get more than 180, then this is not a possible solution, and only this would be. But in this case, it adds to 34 and comes up to be less than 180, leaving room for this third angle. So this is the ambiguous case of the law of sines. So we actually have two different triangles, and we're not done yet. So for this triangle here, what's left to do? We've got a 34-degree angle and a 38-degree angle. How are we going to solve for side C? Yeah. So what can we figure out? In other words, we don't know angle C or side C. So we can't immediately use the law of sines. But what can we figure out real easily?
Angle C.
And what is that?
108.
Okay. Now we can use the law of sines. We have the sine of 34 degrees over 30 equals the sine of 108 over side C. Okay? So that's the first solution. You want me to go through the arithmetic on that, or can you take it from here?
Can we just do one?
Okay. Cross multiply. So we have C times the sine of 34 equals 30 times the sine of 108. So C is equal to the sine of 108 divided by the sine of 34, all times the number 30. You with me on how I got that?
Yeah.
Okay. So put that in your calculator, and you'll come up with C. Tell me what you get, and I'll label it. It better be a number much bigger than 33.
I got 0.839, so maybe I'm plugging it in wrong.
Okay, did you multiply it by 30?
Yeah.
Well, first do the sine of 108 divided by the sine of 34.
Oh, that's what I did wrong. Okay. Oh yeah, I got 51.
Okay. And that makes sense because all triangles, the longest side has to be opposite the biggest angle, and 108 is
Right.
clearly the biggest angle. So that appears to make sense for that answer. Now let's go over and look at this triangle here. Well, what does this angle see?
Oh, 1 second. Is it like 4 degrees?
4 degrees. Okay. So now we have a different side C down here. So we've got the sine of 34 divided by 30, that fixed relationship, is equal to now it's the sine of 4 degrees divided by the new, or side C, but side C from a different triangle. So now this C is going to be the sine of 4 degrees divided by the sine of 34 degrees multiplied by 30. In other words, I'm going to cross multiply again.
Okay. And I got 3.7.
That makes sense also. 3.7, a very small side opposite the smallest angle. And there in a nutshell is the ambiguous case of the law of sines. Now let's just review that. Because had this not fit the scenario, in other words, there's only really a couple of conditions that allow for the ambiguous case, and that is this initial angle that you're given has to be less than 90, and it has to be angle side side. Can't be side angle side, can't be angle side angle. It has to be an angle, the adjacent side and the opposite side. And then the only time, once you figure out what this first angle A is, automatically find out what its supplemental angle is. And then if that supplemental angle added to the only known angle of the triangle is less than 180, then you have an ambiguous case. If it's greater than 180, then you cross that out. You only have one solution. You don't have two solutions. So that's the key, is to always check for this angle. And that's the easiest way to handle the ambiguous case. I've seen math books that have like a whole page devoted to what will give you the ambiguous case, and you have to memorize all these conditions, and it's silly. I've read in another book of this being the way to handle it. This is by far the easiest way to handle the ambiguous case of the law of sines. Okay, this one here. So here we have a similar situation, right? Let's draw a triangle. It doesn't really matter if you draw these triangles to scale or not. Angle A is 26 degrees, side A is 21, and side C, in this case, that side C, that's 33. Well, notice that we still have angle side side, right? And they want us to find side B. And this is C. Okay, let's go through the logic again. It's exactly the same as the previous problem. We have a 26-degree angle less than 90, and we have angle side side, so it's a potential ambiguous. So what's the first thing we need to solve for?
We're going to find angle B.
Yep,
So it's sine 26 over 21 is equal to sine Z.
Sine B.
Uh,
Excuse me, you're right. Sorry.
oh, or is it sine C?
First thing we're going to solve for is C.
Yeah,
We can't do anything with angle B yet because
right.
we don't have a side or the angle. So we do have a side as part of this relationship. So we can figure out angle C. So now that gives us the sine of C equals 33 times the sine of 26 all over 21. What is that number?
0.688.
What's the next step?
We take the inverse of that.
Okay, so angle C equals
43.5.
what's the next step?
Subtract it from 180.
Okay, because we want to find what the other angle C might be.
Right. It's 136.5.
This would have been so much better of a problem had it not been the ambiguous case, just so that they give you two problems, one is, one isn't. In this case, this is also. How do I know? Because if I add that number to this number, I have room for a third angle.
Right.
So both of these are valid. So let's work with them one at a time. So this is 43.5 degrees. Now what's the next step on the triangle on the left?
Set up a new proportion to find...
No, actually there's one step you have to take. In other words, we have the proportion between angle A and side A. We have it between angle C and side C. We still don't have anything between the B's. So we need to take an in-between step. Can you figure out angle B?
Oh, yeah. Or wait, yeah, we can now.
Okay.
So it's sine 26 over 21 is equal to sine 43.5 over B.
No. You have to make sure you're dealing with the angle and its opposite side.
Oh, so it's 136.5.
What is angle B?
136.5.
No. That's angle B in our second triangle. Excuse me. That's angle C in our second triangle. We got two triangles here that are going to satisfy these conditions. In other words, we do have the ambiguous case. That's why I said it had been a better problem had they made it not be ambiguous, and then at least you could see how it's not ambiguous. But the first thing we need to figure out is this angle B.
Oh, so it's 110.5.
Now you can go from there. In other words, now you can use the law of sines to figure out that side B in our first triangle.
Right.
So what goes here?
So it's sine 110.5 over B.
Yes, over little b.
Right.
Okay, so you can solve that.
Uh-huh.
Okay, now let's talk about the second triangle. In our second triangle, angle C is 136. .5. Angle A is still 26.
Mm-hmm.
That still has to be 21. This still has to be 30, excuse me, no, that's, oh, we didn't figure out B on this. We just know we could. Okay, so in this triangle, C is obviously not 33.
Yeah. Wait, it still would be 33, right?
Where'd I get lost here?
No, it's still 30. Huh.
No, in this triangle, angle B is the one that changes. Let's see, that's 162.5, so this is 17.5. And yes, this C is 33,
Oh, yeah.
A is 21. 33, 21. So we had angle, side, side. For some reason.
Can B change because the angle change?
Well, hold on a moment. For some reason, it confuses me whenever, in other words, it's angle, side, side, but they made these two sides, the bottom and the right, instead of the left and the opposite. Hold on a moment. Let's see if I can straighten my mind out here. I don't think I can without redrawing this thing. I'm going to redraw this, only because I'm confused. In other words, the original triangle, this was A, well, and this was 21, and this was 26, and they gave me 33 as the other side, but you notice that if I make that the other side 33, it's no different than if I make this 33.
Mm-hmm.
This is still angle, side, side. So I'm going to choose to work with this as my model, only because I'm not confused by it. So let's see. We figured out in the first case that this could be 43 here, which made this 110.5, and that was angle C, and that was B. And we solved for little b. Okay?
Mm-hmm.
In the second triangle, let me draw it down here, 136.5. In the second triangle, we still have the 26-degree angle here. Only difference is this angle is now 136.5. This is still C. And this is still 33 here, and this is still 21. So the new angle B for our second triangle is what?
17.5.
Okay, and now we can solve this triangle because we have 26 opposite 21, we have 33 opposite 136, so we have all kinds of that relationship. We merely need to take the sine of 26 over 21 equals the sine of B, no, excuse me, the sine of 17.5 over side B. And now solve for that, and you have your second answer for side B. We'll call this B sub 2. This is B sub 1 up there. That's B sub 2. Now notice the only thing I did between this picture and this picture was I rotated. I flipped the triangle, which doesn't change anything. In other words, I put C at the top, I put B at the top and C to the right. And I didn't need to do that, but like I said, when I have to work with angle, side on the bottom, side opposite, for some reason I get confused by it. And so I always put the two sides being the opposite and the upper left of the known angle that they're giving you.
Okay.
That way, in my head, I can always draw the two triangles this way and this way. And these two angles will always be supplementary if indeed you have the ambiguous case. Both of these first two were. So hopefully they'll give us one that is not, so we can see how that plays out.
Mm-hmm.
All right, this looks like it probably is going to be one that isn't. The reason I say that is because the closer this angle is to now, well, this isn't even a possibility here, where they're giving us two angles. So in this, we have 83 degrees. Angle A is 23 degrees. And side B is 32. So they want side A. Okay. So this is angle B. What do we need to do here?
We need to find, well, we can find angle B.
Let's do that. Because at this point, we do not have a relationship that the law of sines requires.
Right. It's 74 degrees.
And there's also no possibility of ambiguity. So let's set it up. I'll let you do the math, but
so is it sine 23 over A is equal to sine 74 over 32?
yeah. There's only one unknown there. And you'll be solving directly for side A. You won't have to take any inverse signs.
Right.
Okay. And that's all they ask for, but we could also solve for side C if they wanted us to solve the whole triangle using the same law of sines. Okay. So whenever they give you two angles, always know that that's an easy problem because you can always immediately get the third angle. And then you automatically have a law of sines application that's non-ambiguous.
Okay.
Next one. Okay, good. They finally gave us one that can't be the law of sines. I mean the ambiguous case, because that's not less than 90 degrees. I'm going to set it up like that also, just so we're always oriented kind of the same way. In other words, we still have angle, side, side. So if it weren't for the fact that this was greater than 101 degrees, it potentially could be the ambiguous case. So the fact that I know it's not makes it easier. So let's go through this one. What's the first thing you're going to figure out?
Can we figure out angles A and B?
Not A yet. We can figure out angle B because we have the relationship between opposite side and angle.
Right.
So we have sine of 101
right,
over what?
over 30 is equal to sine B over 34.
Okay, let's go through that. So what is sine B equal to?
Is this where, do we have to take the inverse of something?
Well, not yet. Let's do the algebra. That's why I'm asking.
Okay. So
What's sine B equal to?
it is 1.1
Okay. And what is the problem with that?
It's bigger than 1.
Okay. In other words, there is no angle B that is equal to that.
Right.
Means this is an impossible triangle. And we should have seen that from the get-go because I had a side opposite what has to be the largest angle in the triangle that wasn't the biggest side. There's no way this can be 30 and this can be 34.
Right.
And if you don't spot that when you're solving these, you get it pointed out very adamantly to you by the law of sines, which then tells you that the sine of that angle is a number greater than 1 or less than negative 1. So the moment you see this, you know impossible triangle.
Okay.
Okay? Okay, we have angle, side, side. So this is a possible ambiguous. And the way I always write these, no matter how they give it to you, is I put the angle they're giving us on the lower left.
Right, me too.
I put the other side on the upper left, not the lower right.
Okay.
Just, that's a personal preference for me. Makes that A and that C. So what's the next step?
We have to find angle A to find angle C.
Okay, so the next equation?
So sine 29 over 20 is equal to sine A over 29.
Go ahead and figure out what sine A is equal to.
So because I'm going to move them.
What'd you get for sine A?
1 second. So I got 0.7029, but I have to find the inverse of that.
That's the next step. Okay, so A is equal to what?
44.7
Or,
or 45.
well, no, by the or I meant this is the case where you have to check the supplemental angle, because this is a potential ambiguous case for the law of sines. Merely because it's angle side side, and that's less than 90. Whenever that's true, you always have to check the other angle also. In other words, this is the first quadrant angle for that. There's a second quadrant angle also.
Okay. Is it 135?
Now we need to check whether that added to the original known angle exceeds 180.
No,
Which means we have both cases. So we have one case that's 44.7,
right.
and then we have another case where that angle is 135.3. And notice that both triangles have the same three conditions. So they want to find side C. Well, they want to find angle C. That's all they want to find. So I don't need to do much to find angle C here. What's angle C there?
Right. It's 106.3.
And in this case, angle C sub 2 is what?
It's 15.7.
So there's our two answers. We have an angle 1 and an angle, we have a C1 and a C sub 2.
Okay.
They still have not given us one yet that was not the ambiguous case. I wish they would. Maybe this will be it. All right. I'm going to draw it the same. Always label the angle that you know, and the side that you know, and then side A is going to be up here. This is angle A, this is angle C, and here we want to find angle A. Okay? Get me started?
So, so sine 46 over 33 is equal to sine A over 34.
Okay, tell me what sine A is equal to.
Okay. It's 0.74.
And tell me what angle A is equal to.
Some 78 or 47.8.
Or what?
Or 132.2.
Gosh. Still, it's an ambiguous one. So the two answers are that and that. They couldn't find one question to give you where it was not an ambiguous case? Surely this one. Surely this one. Because you're going to come away from this set of exercises thinking there's always two answers.
Right.
And there aren't. Most of the time, that's not ambiguous. This shouldn't be. closer we get to 90 degrees, the harder it is for it to be ambiguous. Okay?
Mm-hmm.
What next?
So, we can do sine 86 over 25 is equal to sine b over 35.
What's sine b equal to? Again, they've given us an impossible one.
Yeah, that's impossible.
I can't believe that. Okay. And let's look at this one. 103 degrees. And again, I'm not worrying about drawing it to scale. And here it doesn't matter because it cannot be ambiguous. I don't even have to allow for that, so I can put C wherever I want and B wherever I want. Okay, what's the next step? They want angle C.
Oh, so sine 103 over 20 is equal to sine C over 9.
Okay. Sine C equals what? The fastest way to do this, Morgan, is to figure out what the sine of 103 over 20 is and multiply it by this denominator, 9.
So it's 0.44.
Okay, what is C?
Or 26.
And that's it. We don't need to check the supplemental angle.
Right.
Because the supplemental angle here would be 154 degrees, and 154 added to 103 is way more than 180.
Right.
That's how you prove that it's not ambiguous. In other words, if they would actually give us a problem that was not ambiguous, we would see that when we took that supplemental angle and added to the known angle, it exceeds 180, and therefore you do not have ambiguity.
Right.
All right. That's all I got on this page.
Yeah. Let's see if I have anything else. I have a quiz review that I got. I can send it really fast.
Okay. Or if you can just verbalize them, if you want.
Oh, yeah.
If it's more of the same. Have you done law of cosines yet? I noticed we didn't have any law of cosines.
I don't think we have.
Okay. That's coming next.
Oh, here. I have to go get it really fast. Be right back. Okay. We could do, oh, it says state the number of possible triangles that can be found using the given measurements. And so angle C is 107. Side B is 31. And then side C is 27.
Is this going to be a possible triangle? Just looking at it?
Yeah, no.
Exactly. In other words, we don't even need to go through it.
Right.
If we tried using the law of sines, we would get the sine of b is greater than 1. Because there's no way 27 can be opposite the largest angle in the triangle.
Right. Okay. The next one is angle B is 156. Side A is 26. And then side B is 47.
Okay, this has possibilities. Cannot be ambiguous, right? Even though it's angle, side, side, the fact that this is greater than 90 means that if there is a solution, there's only one.
Right.
Okay, so how do we figure out? We only need to figure out sine A to know that there is one solution. That's all the further we need to go. In other words, I need angle A.
Oh, okay, so sine 156 over 47 is equal to sine A over 26.
Okay, so sine A is equal to what? And as soon as you get this number, you'll have the answer to the problem. You don't need to find out angle A. You just need to make sure that the sine of A is within its domain, or rather within its range.
Right. It's 2.3, or 0.23, I mean.
I was going to say, that doesn't sound right. Okay. So one solution.
Okay.
That's all we need to do. You don't actually need to figure out what angle A is. Go ahead and take the inverse sine of 0.23. What do you get?
Um, 13.3.
Okay. So now you know there's room for three angles.
Okay. And then we could do, it says solve each triangle and round your answer to the nearest 10.
Okay.
So I would just draw a triangle, and then I can tell you them. And then starting from the left is just angle A, but I don't know what it is. And then at top.
Let's start with the angle we know what it is and put it
Oh,
up.
we don't know any angles, we just know the sides.
Okay, that's a law of cosines problem. What are the sides?
12, 11, and 14.
Okay. Law of cosines is whenever you cannot establish that relationship between one angle and an opposite side. And this is certainly a case. Okay? Where we don't know the sine of any angle over its opposite side. We do not know that ratio. So we have the law of cosines, which says it's a little bit like the Pythagorean theorem. Starts out like the Pythagorean theorem. Or you can switch any of these letters around. In other words, I could solve for a squared equals b squared plus c squared minus 2bc cosine of angle A. And finally, the third case is b squared equals a squared plus c squared minus 2ac cosine of b. Make sure you see what's unique about each of these. In other words, the AB here comes from this A and that B. The BC comes from that B and that C. The angle is always the side. Okay? So, since we only know three sides, let's label it A, B, and C. As soon as we can figure out one angle, we're home free. Well, let's use this one.
Okay.
And figure out angle A. So tell me what equation I'm going to write.
So is it a squared equals,
What is A?
oh, a is that 11?
Uh-huh. So it's 11 squared equals what?
14 squared plus 12 squared minus 2 4 times 14, or yeah,
It's those same two numbers. Always.
times 12, and then cosine, and is that 11 too?
Cosine of what?
11, or cosine of A.
A.
Okay.
Notice that there's only one unknown in that equation.
Right.
And I can solve for A because of it. So let's go ahead and do the math on this one. What's 11 squared? 121. 14 squared is
196.
plus 144. What's 2 times 14 times 12?
Is 336.
Now do the algebra.
So 196 plus 144 is 340 minus 336.
No. Minus 336. How do you solve this algebraically?
Oh.
What's the sum of these two?
Is 340.
It's the next step algebraically here.
Do you divide by 340?
Subtract 340 from both sides. We're trying to solve for that, so we have to isolate that.
Okay.
So this is the same as if I said 6 equals 8 minus 4x. Okay, I'm going to subtract 8 from both sides, divide both sides by minus 4, and solve for x. Well,
Okay.
the algebra is exactly the same. So what's 121 minus 340?
Negative 219.
Okay, now we have this. What's the next step?
Divide by negative 336.
Okay, so now we have cosine of A equals what?
Is it 0.653 or 2? I mean.
I'm not checking these with my calculator, so I'm counting on you. So now what is angle A?
Or it's not 3, it's 2, but then do I do cosine, or do I divide?
How do you solve that? If the cosine of A is equal to 0.653, how do I get A?
Oh, you have to take the inverse of it?
Yes.
Okay. It's 49.3.
Okay, so we found one angle, 49.3. Now, as in every case where you have to use the law of cosines, you, at some point in the problem, have to use the law of sines. In other words, that got us one angle, and now we have that angle opposite side relationship, So we can finish this problem using the law of sines, and I'll let you do that.
Okay.
But you never can solve a triangle with just the law of cosines. There's only two situations where you have to use the law of cosines. One of them is where you have only the three sides of the triangle, like this problem. The other situation, and incidentally, whenever you have three sides, it's never ambiguous. It's only going to be one solution here. I don't need to check for ambiguity, even though that's less than 90, and I got angle side side. It's not possible for it to be ambiguous because they gave us all three sides. That can't be an ambiguous triangle. So the only thing you need to do to finish this problem out is to figure out side B or C using the law of sines, and then you can get the third angle by just subtracting the other two from 180.
Right, okay.
Now, let me just give you the only other situation where you're going to need to use the law of cosines, and that is if you have side angle side. In other words, if I know that one's 10 and that one's 9 and that's 50 degrees, notice that I have three pieces of information, but I do not have a sine opposite side relationship or ratio.
Okay.
So there's no way to use the law of sines as the first step here. But I can use the law of cosines. So how would I set up my equation to solve that problem right there?
Could you do...
This is side A.
You need to do...
Little a. So what's the law of cosines?
Could you use this? Oh.
You have to use the law of cosines.
So sine.
No, remember what the law of cosines is? The law of cosines are these three things right here.
Oh, okay. So could you use c squared or b squared?
No. We do know the sine of A, or the cosine of A. So let's use the a squared one. In other words, we want to use this one. Why? Because we know everything on the right side. Notice that the right side of this equation, we're going to know all of these angles. We know B, we know C, we know B and C, and we know that angle. So we're going to be able to solve for little a.
Oh, okay.
It's a little different. Last time we had to solve for this angle using the law of cosines. But this is a more typical, well, there's only two situations where you use the law of cosines. And that's this one and the previous problem. And both of them result in a little bit different solution. Notice here we solved for cosine of A and had to take the inverse of this number to get that angle. And that's not what we're going to do here. Because we know that angle already, we're solving for a side. So we will solve for A. We will have A squared equals 9 squared plus 10 squared minus 2 times 10 times 9 times the cosine of 50 degrees, which is a number.
Right.
So once I get that number, take the square root of both sides and I'll have A.
Okay.
Once I get little a, now I have that relationship that I'm looking for, and I can finish out the problem, again using the law of sines. You always finish out these problems using the law of sines, even if you begin them with the law of cosines.
Okay, that makes sense.
Okay.
Okay.
Well, good luck on your quiz.
Thank you.
And hopefully you'll, I don't know why they didn't give you a triangle that was not ambiguous. That's silly.
I know.
Okay, talk to you next time, Morgan.
Okay.
Bye-bye.